Hello, this is the project demo video of CSCI 5570, and this is Shenjia Chen. In this project, I implemented an RDMA-based key-value store and experimented 3 different hash table designs on it. And in this video, I will first briefly introduce my project named MyKV, and then I will show the code and run a simple shell demo to show that it is actually working. And after that, I will show how I conduct experiments and talk about some key findings about this project. And here is the overview of MyKV. It is composed with 4 main modules: RPC module, memory manager, base table, and the connection manager. And next, I will introduce these modules as I scan through the code. So the first module is the base table module. It is a generic hash table that abstracts all the KV operations to facilitate the implementation of the RPC server and RPC clients. And it can be switched to 3 different hash table designs: Cocoa hash, hopscotch hash, and finally a simple hash table using linked list to solve the collision. So the second module is the connection manager module. It is an abstraction layer to perform RDMA operations to facilitate the implementation of RPC server. As we can see that it provides the post-receive, post-send, POL1s, and the read table, some one-sided operations. And also it is responsible for construct RDMA connections using sockets to exchange the required information to connect the QPs on both sides of the RPC server and RPC client. So another module is the RPC module. It can be separated to the RPC client and the RPC server. The RPC client performs all the KV operations for the client. It provides the put, delete, and get operations. And there are 2 implementations of the get operation, which are the 2-sided get and the 1-sided get. And the implementation details of these 2 get operations can be found in my project report. And the RPC server will start 2 threads. The first one is to handle the user connect requests from the clients using the connection manager. And the second thread is to pull the completions from the RDMA completion queue and dispatch this work request to other threads to perform the KV operations. Finally, the memory manager is used by the base table module to allocate memories, for example, to allocate item buckets. And it is required because the memory that can perform RDMA operations need to be registered by the libIB verbs or by the RDMA-enabled network interface card. And however, the register memory operation is very expensive, so I pre-allocate a large portion of memory and use this memory manager to manage it. And next, I will perform a simple demo using this MyKV shell to show it is working. Okay, so I'm now starting 2 servers and on different machines. So let's first start this MyKV server using this command line, and this is the table type specified by the command line. And now the server is started. And then let's start this MyKV shell using the IP and the table type. The table type must be matched with each other, otherwise the operations will fail. And now this MyKV shell is working, and the MyKV server show that there is 1 client QP connected. And let's put AAA10 and get AAA. So we get the value 10, and we update this value by put AAA100 and now get AAA. So we can find the value is 100. And if we now quit this shell and restart this shell, and let's get AAA again, so it will get 100. So this value is actually stored. And if we perform delete AAA, then the AAA will be deleted. We can perform get AAA to try that. It will show that get is failed because the key is not found. And here shows that another client is connected. So this proves that MyKV is actually working. Next, I will show how I conduct experiments. Here we use the YCSBC as the benchmark to test its throughput and latency. For the throughput, we just integrate the MyKV into the YCSB benchmark. And for the latency, it did not provide the latency measurement, so I implemented on my own by adding this latency execution logic. And now let's do some executions. And first we need to initialize the libs because YCSBC will need to use the mykv.so, and this will tell him how to find it. And now let's start YCSBC. We assign DB as mykv and the table as hopscotch, and the workload as workload C, and start it. So we can see that 1,000 records is loaded, and now the throughput is coming. Oh, that throughput is pretty low because it is only one thread conducting this experiment. So we can speed it up by adding more threads. For example, 10 threads. So it will be pretty quicker, right? And finally, I will show some experimental results. And these two figures shows the throughput of mykv compared with Redis. As we can see that the throughput of mykv is way higher than Redis. And as for the 3-hash table designs, the hopscotch hash performs the best. And this is the latency diagram as we increase the number of threads. And we can see that the latency of Redis is way higher than that of RDMA-based key-value stores because of the kernel bypass and the CPU bypass feature of RDMA. And that's all. Thank you.